Hello, everybody. Welcome to another episode of Vector Space Talks. Today I'm here with Samir from Gatling, and we are going to try to break Quadrant Cloud. Right, Samir? Say hi to
Hello everyone. Yeah. Today we will try to. I will try to back Quadrant.
Yeah, exactly. We're load testing Quadrant Cloud, see how much we can make it stretch. And Samir has some really, really interesting demonstrations. I was just checking it out, so I'm pretty excited. Yeah, Samir, why don't you introduce yourself and tell us a little bit about Gatling and load testing?
Yeah, sure. So I'm Samir. So I'm like developer advocate at Gatling. It's a load testing tool, and the main thing of the load testing tool is mostly seeing like if a lot of people or some people coming into your website, LLM, etc., if your website crash.
Yeah, exactly. So basically, trying to see how much, um, how reliable it is. And today we're working with the Quadrant gRPC API to test everything. So let's get started. Here is the presentation, and I'll let you take over, Samir.
Yeah, some slide, but so what we do at Gatling, like I said, is a load testing solution. So we have it's kind of like Quadrant. We have an open source version and also an enterprise version. But what we think about load testing is load testing as code. So you just use like JavaScript, Java, Kotlin, Scala. You create your script to load test. So for example, your script will be go into the Quadrant gRPC API, send, I don't know, like 1 million points and seeing if everything is good or crash. And you can do it for gRPC, it can be on Java, Kotlin, and Scala. JavaScript is mostly right now HTTP, and we have a lot of protocols, so like HTTP, gRPC, SSE. SSE is mostly used for LLM and other stuff, but in AI mostly for LLM, GMS, etc. Now let's use the floor for presenting Quadrant.
Yeah, absolutely. So, if you are not familiar with Quadrant yet, we are a high performance vector search engine written in Rust and built for recommendation engines, fraud detection systems, RAG. Um, uh, we act also as a memory layer for like agents and stuff like that. So, basically, everything that you need high performance working with vectors, definitely you should check us out. We are open source, so you can run anywhere that you want. And we also have the cloud version, which is basically the most scalable and production ready version of Quadrant. So, yeah.
And now let's go to the first demo. So now, if I first I will showcase that I have like a free chair of Quadrant because we will focus on the free chair of Quadrant. So I have a free chair on AWS. I have nothing inside of it. So no collection, no points, nothing.
Amazing. And before we get started, can you explain a little bit of what we're going to do here?
So right now, the first demonstration is try to find the maximum collection that the free chair of Quadrant can have, like before it crash or before it say no, I don't want any more collection at once. So now if yeah, my mouse.
Amazing.
So
So we're seeing how many collections can we fit
yeah.
before everything breaks.
ah, yeah, it's mostly crashing, I think, but let's see. But right now, like I will do this simulation into like Java. Since I say like we're doing load testing as code, it's mostly using Java for gRPC. First, what I do is just really simple importing like a not importing but creating a package. What here it's importing what I need from Gatling and from Quadrant because on Gatling when you try to load test the RPC, you need to get the proto file from the application. Since Quadrant is open source, I just go on the GitHub and find all the proto, so like collection, we got one, etc. After that, what I do is connecting to my clusters, so with URL and API key. You will see a lot of URL and API key in plain text. Don't worry. I will just remove all the cluster just after. And right now is where Gatling works. So scenario builder permit to create a scenarios. You can see a scenarios as a recipe. So what the user will do into your website. So the first one is optimized collection. So you will see why I call it optimized collection just after. But the scenario is pretty easy. So first I give it a name. So load test collection. It can be another name, so like a load test collection, blah, blah, blah with optimize. After that, I'm creating an exec. So exec is just permit inside of it, you list what the user will do. And the session, you can see it as a session of your browser. It will permit to save information for the scenarios. So for example, what I do, it's just initialize. Yeah, it's French, but initialize a thing to 0, and I will just add 1 each time. And here, what it's good, especially when I want to see how many collection fit inside of quadrant, here I do the loop. So it's as long as is a loop. And the loop is until, like typically this is until quadrant crash. So all it is because if quadrant don't send me okay, it's because it's doing something. So mostly crashing or mostly saying I have an error. And on the loop,
Or maybe like it's full of memory and
yeah, full
some
of
sort of, yeah.
yeah, sometimes it's just full of memory, full of disk, or full of something
Yeah.
else. And so, and after like this thing is mostly gRPC stuff. So I'm creating my request and send Unary to create a collection on Quadrant. And after here, I just like personalize my collection. I say, okay, the name of my collection will be test plus the name set on display HNSW. So Sabrina will explain better than me, but we put it on 0. And
Yeah.
also on this one, we put like contextualization and vector config. After, at the end, I just build like a normal gRPC. And here, like on check, it's a feature of Gatling. So when you send a request, you assume that you will get an answer. So for example, from Quadrant, you will say, okay, everything is good, the collection is created. So right here, what I check is typically getting the answer from Quadrant and checking if the result is true, because when you create a collection, Quadrant says false or true. And here I save the status code in order to see if Quadrant crashed or Quadrant didn't crash. And here it's just like a small exec to add 1 to my thing. Now if you want to explain to the rest.
Yeah, I think just before we get started, a quick good sense warning here is do not create so many collections like this.
Yeah.
This is definitely just a fun experiment, but if you're working with Quadrant, usually you only want to create another collection in case your data set is very different from one to another. Maybe you want to work with a very different data set, and maybe use different distance metrics and stuff like that. So that is usually the case. But even if you need to separate users, if you want to create some sort of privacy, you can still use multi-tenancy and other types of optimizations in Quadrant within the same collection. So yeah, just be aware, try not to create so many collections. And this collection specifically, this type of collection that we're creating has a few optimizations in it. We're still not adding a lot of points. We're just creating the collection. So
Yeah.
maybe I can explain like how this affects the points within the collection when we start inserting points.
Okay. So now, and just after I have just the same scenarios, but for not optimized collection. So it's it's the
Yeah.
same thing, but I remove payload, I remove on disk, it's the same thing. I remove all the optimize that you can do.
Yeah.
And here it's So this is not obligatory. It's mostly because we have two scenarios. I just say like, I just get a Java properties. So it's like an argument you pass on your program. And I just say like, okay, if the person wants the no opti scenarios, launch this one. If not, create a lot of optimized collection. And you can see the setup as how Gatling will send the users. You have a multiple way. We can send a lot of people on Quadrant, on also project. But right now, what we do is injecting one person at once. But if you want to try with a lot of person, you can do it. You just need to increase this number. So now, after that, I have my my package just here. Now, if I want, I just need to do this thing, enterprise. No, sorry, Gatling.
Awesome. So here we are sending one person at once, creating one collection,
Yes, total. Yeah.
either optimized or non-optimized, and see when it's enough, when Quadrant
Yeah. So right
doesn't
now,
allow.
yeah.
Yeah.
So this simulation is doing this, and right now I'm packaging the application as a jar file. So and I will just, because right now we will test on Gatling Enterprise because of two things. So on Gatling Enterprise, the report is much better, and also you can compare it really easily all the scenarios. But also because on gRPC, on the open source version, you are limited to 5 minutes. Like you can only test 5 minutes. So, but on Gatling Enterprise is unlimited. So now if I have my package, so now just upload my gRPC package. Now it's the time to find it. So user article quadrant. So now I've uploaded it. And now on my simulation, I already create a simulation, but I will show you how to do it. So now if I did. So to create a simulation on Gatling Enterprise, you just put a name. I just keep it like quadrant simulation, but you can put whatever you want. Here you can choose a simulation, point simulation and create simulation. You will see it just after. Don't worry, it's just a spoil, but you will see it after. So right now I will just use a collection simulation. On the location, you can get like whatever kind of whatever country you want. So Hong Kong, Tokyo, Mumbai, Paris, Sao Paulo. I just choose Paris because I'm living near Paris, but we can test with other destinations after. You can also use your private servers in order to send users with private. And dedicated IP is if you want a fixed IP. And here is where I leak a lot of things. So you can use this one if you want, like, but after it will be deleted. So you can try to use it, but it will be deleted just after. So now I will just put the good URL of my clusters.
It's already maxed anyway, right, Samir?
Yeah, it will be max. And now on this one, first I would just want to use like, so if I showcase it back, I will just first create the collection not optimized to see like how it goes. So I will just check this, just take this, not this one. And now what I can do is just pushing here my key, so scenarios, not optimized, not opti. You can also, so right now it's Java properties and JavaScript, but you can also put environment variable. So if you want to export it on your shell. And the last two things, I will not choose it, but stop criteria permit to see like if you need to, I don't know, like you add new features in tech and you break everything, you can say, I want this, I want my simulation to stop if my memory is like 45 gigabytes, for example. So now we'll just save and launch. And now what it will do first, it will building my simulation. So I can see some logs. So it will take the jar file I took, put all the Java properties. And now it's time to wait because it will take like some time to build. After it will deploy, so deploy building, not building, but launch the load generators from Paris, and after it will inject people. But right now we can see that we have anything in Quadrant right now. We just need to wait.
Yeah, and what's happening here is that we are opening the connection with Quadrants, sending the request to create the collection, and closing the connection. So basically, Quadrant, when it receives the requests to create the collection, it starts setting up the collection, starts creating the everything that you set up in the optimizer settings, setting up the indexing, setting up the payloads in that collection, and that takes up some RAM and also some disk, especially while still creating the collection. So definitely we expect to see those two increasing.
Yeah, so right now, like for example, we see that it's injecting, so I do some requests. Now if I go back to Quadrant, it's begin to do a lot of requests. So right now we are like in a lot. If I refresh, I'm like 23 page of collection. And now if I go back, yeah, on Quadrant Cloud is kind of what you said. If I go back on metrics, 5 minutes, like there is a beginning of of RAM, not a lot, but there is a beginning of using it. Well, now we're like already at what, nearly 200. It will be refresh and nearly 200. And what now? Yeah, what now? What we does, like you said, is really like just sending a request to Quadrant saying, I want this collection to be created, not optimized, and I close the collection, not collection, but I close the request.
Exactly, and I'm actually admired that we can take up so many collections so fast, but definitely excited for what that number, that final number will look like.
Yeah, normally it will finish like not really like in maybe 1 minute, not 1 minute, but maybe like at the end, like 2 minutes or. But right now it's 300. It's not even optimized for 300. So
No, yeah, exactly. Again, not advised.
yeah, and also what we do is like right now it's mostly, I will not say DDoS, but we just send a request at one time. We don't really, right now I don't really think about like, yeah, but if I wait like I don't know 5 minutes and then redo the stuff. So right now it's really like at once. Yeah, but
Yeah,
nearly
exactly.
500 maybe.
And this is so important to test when you
Oh.
are creating a website for. Oh yeah, we got something's not right there. Oh yeah, the
Yeah.
cluster.
Yeah, so the thing is, right now, yeah, we got an error. We say like, I got a missing message. It's because Quadrant didn't answer me. Like not the thing I was wanted. So I got an error, which is normal. So right now the number of total collection is this number -1. So because the last one is not really crashing Quadrant. It's just that after Quadrant need to use a lot of RAM to uh, like to wait,
Start
let me
setting
just check
up the
that. Yeah,
collections.
setting
Yeah,
sense collection. So if you wait some time, you still can use the clusters. And like now, if I show you the report, because right now it's just a summary of the report. If I show the report, you have the whole information. So for example, you can see the number of requests and response by second, for example. Also, you can see the response time percentile. So right now, if I take like in the middle, the minimum of response time, not the minimum, but the mean of the response time is like 263 milliseconds. So it's pretty fast. And it's a minimum, like the mean, like the maximum is like 267 milliseconds.
yeah,
And
pretty
after,
fast.
yeah, you can also check like response time distribution, the error by second, but the error by second is mostly the last one, since like Quadrant don't really crash. It's just like going into not to regimod, but to try to like optimize the collection, etc. We see that I have only one users, I revive. I have one concurrent user, which is normal because I'm the only one. And also you can see a lot of load generators. So the load generators is like the server will send the user. You can see the CPU, you can see the RAM, you can see everything.
Can you tell me if those 200 milliseconds also include the time that it takes to open and close the connection, or is it
It
just the time that is communicating with Quadrant?
is the whole request until we got an answer. So it's beginning of the request is when we send the request to when Quadrant say, okay, like the request is done.
Okay, okay.
Not the request, not the collection is created, but like the end of the
request, yeah.
request. Yeah, so right now it's mostly a lot of RAM. I will. It's
Yeah, if
just
we
like
go to the
recovering
logs,
collection.
you can kind of see what's going on.
Yeah,
Yeah.
it's recovering collection, and but I will need to wait for like 500, not 500, but 400, I think something. I will not wait, so I will just
Yeah.
right now delete this one.
Let's go to the next experiment. The reason, again, the quick explanation, the reason this happens is because each collection takes a little bit of RAM and disk to be processed and set up. And when you do those all at once, it doesn't give the time for Quadrant to set up the whole thing. So
Yeah,
it needs to stop you and just organize everything internally.
yeah. So now we'll just do the optimized version for collection. So now I have my clusters. If it's work, yeah, I need to remove the HTTP. And you can also, you will still see my API key. Don't do this in production, but if you want, we can take a screen. So right now the API key. Okay, so now it will be the optimized version. So now we'll just save it. Yeah, also I will, so right now we're from Paris. For this one, I will keep Paris to really compare just after. But on point, like on query, I will change the city to see other country. So now I will just save and launch. Oh, I didn't even, okay, it's healthy. So now we'll just open it. So now it will be the same thing. So we don't have any collection. Now it's still building. And also, like, since it's building, you can also, like, because right now the thing is just called 23. We don't really know what is about. So I can just add a run title. I will just say collection not optimized. Okay, and also you can see which person trigger it. Because right now you can see the person, or if you want to put it inside the CI/CD thing, don't put like try to load test collection in Quadrant, but if you want to put your load test inside the CI/CD, you can do it with Gatling. We have some integration with Jenkins, GitLab, GitHub, etc. So now if I go back to the simulation, okay, so now it's injecting. Now if I go, I have some collection. If I click on it, info, yeah. Okay, so we have like binary, always true, always like on RAM, on disk, payload, etc., etc.
Amazing. Yeah, this is also a good time to explain like where you can find this information about your collection, and basically showing all configurations that you can possibly do with it.
Yeah,
And yeah, this one is actually optimized with binary, right?
yeah. Let me just show you. It will be, I think, better before question crash, but it's
Yeah.
here. So here.
Yeah, it's with binary quantization. And also, it's not set up to start the indexing process. So because it won't start the index process, maybe this means that creating this collection will take less RAM to set it up. So let's see how it goes,
Yeah,
if the result's better. But it also has other optimizations that may or may not affect the way it's actually set up the process. So
so when I think
interesting.
that last one was okay, 400.
Okay,
So
so we're already, you're getting there already. Yeah.
yeah. Yeah, because the thing with Gatling is really like we arrive to really simulate like fast and send a lot of users. But now it's only one, so it's not really a lot, but we can simulate 1 million, multiple thousands of users. Really easy.
What's the max of
The
how
max of
many users? How many
I
users
don't
can I
sh-
send
I
maximum?
I don't really know the maximum, but I know some company which really does a lot of like a lot of of user. But I don't have the maximum. I can ask and I will see like what is the maximum of users.
Yeah.
But
Can you explain how a company would use it like regularly to optimize
o-
their yeah.
yes, so you have kind of like two type of people. So you have people using it to test in a specialized situations. For example, Black Fridays. I want to see if it crash or not, promotion, etc. And you have also another one, which is really in a CI/CD. So they use Gatling and the CI/CD to see if maybe like a new feature uh, improve or not improve the response time, for example. So because right now you got a lot of studies saying like if the website take like 2 or 3 seconds to load, people just leave just leave the
Yeah.
website. And also it's permit to see like because maybe you had a new things. For example, Apple India was down when they released a new iPhone. So it's Apple, like it's Apple, so they don't really care about it. They have something for this, but they don't really fear like to lose a sales. But if you are like I don't know, like a smaller e-commerce or a middle e-commerce, if you crash for 5 minutes, people will just leave and never come back. So
Exactly. Yeah.
it permit to do this, and also saying if you uh, website or like website application is really reliable, and if you can really have like I don't know like 10 million, no, 10 million is pretty big, but 1 million user into the application and seeing if it crashes or not. But right now those quadrant what oh yeah service so it
Okay,
crashed.
so we reached the top. Yeah.
Yeah, it's the same thing, so it's like yeah, no, this one is request. Yeah, the same thing is the RAM. And if I check on the log, the same thing, it will just like recovering collection. So now if I go back on Gatling, I will just say collection optimize. So now if I will have the same information as report. So now if I just close it. So now it's kind of the same time for creating the collection, but right now it's pretty hard to see like, okay, I have my two reports. So you are one way to putting the two report like in two different tabs. But what we have at Gatling, you can just compare one. So I will just compare collection optimize and collection not optimize. And I will just see like the response time. So we can just check one. So we see that collection not optimized take a long, like 3% more time to create a collection, to create the collection and get the answer for the 50% chill.
Yeah,
So
that's
yeah,
interesting, but it's very close one to the other, so I think it doesn't actually
it's
matter,
depend like
right?
for 99.99%, you got like 12%.
Okay, yeah. So for collections with optimizations, it takes a little bit more time for the system to process the optimizations. It does make sense.
Yeah, and also for the maximum percentile, like the response time maximum, you got like plus 12. But it's normal because like it's faster to do it like this, but it's better to use like optimized collections than not optimized. But even not in term of load test, but also in term like of using quadrants, it's better to have like optimized collection.
Yeah, 100%. And we're gonna see exactly the difference
Yeah.
when we try to load test with points, right?
Yes. Yeah. So right now, if I will just go back, because it takes some time for for points, so I just have a small video. So so on the video, I just have another clusters, which is like a free chair. I don't really like it's a free chair on Google this time. Maybe it will impact, but I got other cluster. I just show that I have a collection, like a test zero collection. And the info is not really optimized. It's just like a normal ones. They don't have binary things. They don't have nothing. Yeah, I don't have any points. So now if I go back on the code, so it's, I can do it like this. So on the code, what I have, it's the same stuff. So first I'm creating the gRPC, I'm connecting to Quadrant. This part is the same thing. I'm using session. It's kind of like this, is kind of way to save information and share it with other things. So right now I'm just putting that I want to test the 0, so my collection. The size of my collection is 512. It's what I created just before. And after I just loop. So I just creating a list of points. I just have a list of cities, which is from France, Paris, Lyon, big city in France. And here what I do is just creating 1000 points at one time with a payload, which is called city. And I just put a random city. And after I just creating a list of points, I send it to Quadrant. So here, which set weight to true. And after on the check is really just getting the response and the status code. Also, the really good part of Gatling, it's since is code, you can easily personalize your code. So here, for example, I can just, in a function of Gatling, so exec is a function of Gatling, I can just do for loop, so two for loop, put my Java code I have in another stuff. So it's pretty modular to do this. So now if I go back on, also
So
it's,
you're creating the what kind of vectors are you creating there?
so right now I just create a normal vectors and just put random thing. Like,
How do you set the dimensions there for the
oh, so
creation?
the dimension is coming from the collection.
Oh yeah, yeah.
I have I know the collection, so I just here I just say, okay, so my vector size is, I get the value from my session and say it's the size of my collection.
Right,
So,
yeah, 100%.
and also it's the same thing. I will just send one user for adding points. So now if I go back to the slide.
So there you're sending 1,000 points per request, right?
Yeah, it's 1000 points by request. So now I will just continue the video because, yep. So now what I do is what I will not showcase, but I just change for the point of simulation. So simulation, I just use Paris. You can add parameters. Yeah, I will update the package. Oop. And now it's building. So I will try not to do the wall building because it takes some time. So when now it's building, if I go back into, okay, so now you see that we are injecting points. So yeah, we see the total of requests is still 0 for now, but it will, yeah, right now it's 29 already. And now if I go back into Quadrant, I see that I got a lot of points really fast. And now after, and I will show you just after the report, because I already have the report. So now if I go back into Quadrant, I just need to connect to the good one.
This is a possible way to bulk upload into Quadrant really fast as well. If you are wondering best ways to bulk upload,
Yeah.
Gatling can help you out.
So now if I do gatling.io,
You're also creating the points in the same request, right? So I wonder if that takes also a bit of the time, since we're talking about such a small scale.
Not sure about it, but I can try after, but not sure about it. But
Okay.
now if I connect, so I have a new one, a new vectors, not new vector. But, okay, so now I have this collection. So yep, this collection is not optimized. I don't have binary thing. I don't have quantization, etc. Right now, I have an error. It's not really. It's a maximum of points because else I don't have enough space disk for optimization. Because if I go back on Matrix, the problem is not the RAM, it's not the CPU, it's really the disk. I have like nearly 5 gigabytes. So if I have more disk, it will be good to add more points. But so right now
Yeah.
I have, so if I go back into this, so if not optimized, you got like this number of points, so 1 million, etc. It's pretty huge for a free chair. So for a free chair, you got this thing, and it's not really, it's not even optimized.
Yeah, 1.6 million's unoptimized. You just put it there. You also add the payload,
Yeah, with the
right?
payload.
With the payload. So that's
Yeah, for
awesome.
example.
And this is 512 dimensions. If you're working with
Yeah.
maybe fast and bad, you're gonna get even more, maybe over 2 million, because the dimensions are 384, if I'm not mistaken.
And now if I show you, so point without optimization, yeah, not comparison. Up. So now we will see, yeah, the last error is not because of Gatling, but it's because of Quadrant, because Quadrant, like instead of saying, yeah, I can create the point, they just tell me, no, I can't, because I don't have space disk, so I can't create the point. And then the report, it's pretty good because we can see the response and like the request and response by second. So we see it's like 1 or 2 by second. And also the response time percentile. So at the beginning, we have like a high spike. At the beginning, like the mean is nearly 1 second at the beginning. And after it's kind of like stabilized, you can really also, what is pretty good, if you can just do this. So right now, if you don't want the whole simulation, you just want to like A to B. So for example, like 5 minutes to 6 minutes, for example, I can see the whole information for it directly. So this part of the graph is only for like the 5 minutes to 6 minutes. More, 5 minutes to 6 minutes. And also, but right now I just have like only one scenarios. But after I will show you, for example, the request, you can filter by scenarios and you can filter by request. For example, if you in your simulation you have like, I don't know, like 2 requests. For example, one to create a collection, just after you add a point, just after you, I don't know why, but you delete the collection. Here you can, when you click on it, you can filter by scenario, like by request. And now what I will do, I have first, before doing point with optimization, because I will need to go on another cluster, I will just show like the time for query a point before on the same cluster. So now if I do query, so query is pretty simple. So query is kind of the same thing, is connecting to like to Quadrant. After that, I'm just putting the same collection, so test 0. You can change it if you want, but the collection will need to be already on Quadrant. And after, I have 2 requests. So the first one is in order to query point without filters, what I do is just use the scroll method of Quadrant. After that, here on check, and it's also one part which is pretty great with Gatling, is you can just put some check here. And for example, in my response, I just say like, okay, so Quadrant, when you get the point, like when you ask for the point, Quadrant send you a list of points with a payload, etc. On Gatling, for the check, you can just check this list and saying like, okay, I want to do this with this list. I want to check if like all my points have a payload. And this is with Gatling. You can do this. You can do a lot of things if you want to do, I don't know, like checking the payload, checking if the vector is a good one, checking if everything. It's really easy to do it. And also if you can do it in Java, Kotlin, and Scala. But it will be for Gatling, it will be the same method. So it will be .sound, it will be .check. So it's pretty easy to convert the Java code to Kotlin or the Kotlin to Scala, etc. And the second request is the same thing, but I query point with filters. Paris because I'm from Paris. And after I check is the same. So now if I go back into my simulation, so now we'll just run. So now we'll just run query. I can just run in. I'll let you choose, Sabrina, if you want the location of the.
Oh yeah, we can do it on São Paulo because I'm in Brazil right now.
Like Sao Paulo. So now just need to check if it's a good API key. Hmm. Yeah,
And
it's
yeah,
a
maybe
problem
just
when you have a lot.
before we do the testing, we are using the scroll method for this
Yeah.
one is a way to query without knowing the IDs. So we're not really using indexing for now.
Yeah. You can also like on if you want to use not scroll, you can use it on the simulation, but for now we just use scroll. So now I will just save and launch. So now it's from Sao Paulo. So maybe it will take more time, but because right now the thing is on. I don't remember where is it located. Yeah, we are on US East. So ah, yeah, I don't really know which one will be. If it was Paris or Sao Paulo, it will take more time from US
Yeah,
East.
yeah,
It's
probably a little bit.
yeah, but
Maybe,
right now,
yeah, maybe if we send it from the US, it would be better. But we're trying here with real world scenario.
yeah, because sometimes you're like
Yeah,
people will query you think will not be in the same city or something.
exactly.
So now we're just deploying. Also, we can see the log. So for example, we start the simulation. Uh, is this one is for the test from Gatling. So it takes approximately 1 minute after we deploy the load generators. Is mostly to like uh, start a machine in Sao Paulo, sending some users from Sao Paulo to my application. So now normally it will be pretty fast to get some thing. So now just say query not optimize. So now it's deployed. Okay,
Nice.
so now we got 2 requests because it's the 2 requests I have made. Now if I go back into the report, so what we can do first is without filters. So without filters, it's kind of like it's one request. So like it's one user for one request. So like it's like just like 150 milliseconds. So it's pretty fast. It's not even like it's it's pretty fast. Like without optimize, it's just this, so it's pretty fast for everyone. Like and after with filters, it's kind of the same. Sorry, with filters. Yeah, just it take more. It like a 50-second more with filters, but it's normal because Quadrant need to find the good point. But it take like
Do you
just
remember if you stored the payloads on disk? Because that may explain also.
yeah.
If you have to reach for the payload on disk, then it adds a little bit of a buffer. But yeah, it does make sense. And this is very interesting because we just added those points in there and we are already able to retrieve it with such speed. And usually you need to wait a little bit of time for the system to start the indexing and start optimizing the collection for you. Even the non-optimized collection, there are optimizations that Quadrant does in the background for when you
Mm.
search and when you do this kind of stuff. It's even better. So very interesting
Yeah,
that we can already see
yeah, and
these
also
so
like
fast.
we can have a table if you want to have a table. You can say you can have all information instead of like if you don't like graph, you can do it, and also you can
Mhm.
export it. Like if I want, I can create a custom report, or I can just share with someone. So I can say like I don't know, like I mean like the I don't know, like the performance team of Quadrant, and I want to share it with someone who don't have access to Gatling. I can just create a link, just put a date, I generate a link, and everyone can access. You don't need a Gatling account. You just go on this link, and the person can see the report. They just can see the report, so it's pretty good. Now, if I go back into another clusters, yeah, it's because like Quadrant just gave me one, like just give one feature by account, so I need to be kind of like
sketchy there, creating
Yeah.
multiple accounts to enjoy the free tier.
So now but it will be the last account, so it's good. So now I just do this. I need to wait for my email. Yep, for the email of Quadrant. Wait, it's a good one. Gatling. Yep. Okay, I got it. Okay, so now it's the one which is optimized. So first we got
Nice.
more points.
How many points there we got?
That's 1 million. So now you got, I think you got like 100,000 more points with the optimized version.
All right. Can we see it on the sorry, can you go back a little bit to collections? Yeah, there is
Sorry.
no there you yeah. So there we see the points. How many points are there? There are 2 million there, no?
The exact count is the exact count from is like 1 million something.
Oh, okay. It's what is that one that I saw test 0?
This one is approximately. So wait, let me check info. Yeah.
Yeah.
But it's kind of like really optimized. So it's really optimized collection. So on disk, quantization by only binary. You can. I think there is one more quantization which permit to get more thing, more than binary.
Yeah. So I think we actually got 2.5 million on that one, right?
So if I see here, like if I check on Quadrant, like on the collection, so Directions collection is 2 million something. If I go on the API with exact2 is 1,000,007.
Interesting.
But
Well,
it's
maybe
better. It's still better than the no optimize.
no, yeah, 100%. But I feel like there's still a bit of a extension there because of optimizations being made, and the status of collection is red. So probably something's happening in the background
Yeah.
because of
It's so right now it's mostly the same thing as before. It's because I not have enough space available for optimization. Because
yeah.
right now what I do is with all of this is maximize. Wait, let me just show them. Maximize the disk usage.
Can you go back to the metrics? There's a very interesting thing there we can talk about.
Yep, this one. Or...
No, can you go up a little bit? Let me see if on the overview we can see it better, I feel like. So we can see like the disk is maxed, but we still have a lot of RAM on the optimized.
Yeah, it's mostly because of the disk.
And this is very interesting because in the non-optimized everything was on RAM and we maxed RAM with 1.6 million, and now we optimize everything and we can, we just use disk more because stuff are going to disk. When you use binary quantization, your original vectors are still kept, but they are moved to disk, and the quantized vectors are stored on RAM. And you can even add the payloads on RAM as well, and that will make searches much faster. And disk is very cheap, so you can add later on if you need. So at the end, if you want to also max the RAM, you would probably get like at least 3 million more vectors, 3 to 4. Yeah.
Maybe, yeah. If I think if I like add
If you had more disks, yeah.
And now, like if I redo, so now if I go back on Gatling Enterprise, so it points with optimization. So first, also what I saw when I was doing my experimentation is much faster to send points when the collection is optimized. Because right now, to send the 1 million something, it was taking 5 minutes only. For the without optimization, it was like more than like 10 minutes. So it's like you
Yeah.
divide by 2, kind of by, no, yeah, even by 3. Yeah, 2, 3, 3 things.
And there are very interesting points to be made there, because to the optimized version of the collection, you're also using disk. You're also inserting points
Yeah,
on disk a lot. So that should make you think that it would take more time, but not really, because when you're optimizing, and maybe you can go back to the code of the optimized collection, but when we are creating the optimized collection, and when basically we want to bulk upload points into Quadrant like we're doing here, we want to disable the indexing process for a while, so that when we send one request with 1,000 points, the system starts, usually right in the non-optimized collection, the system already starts the indexing process. But then when I send more 1,000 points, the system has to redo the indexing process, and that takes up a lot of
yeah,
time. So in this way, when we set there in the HNSW config, maybe you can highlight there amp to 0, it means that we are basically disabling the indexing for that time and just letting us upload the points. And then we can set amp to another value like 16 or 32 later on. I feel, Samir, that you told me 6
yeah,
works
6.
good. Yeah.
Yeah, 6 is good.
6 is good. So you can set that value up later on to start building the index uh, and be able to search with similarity search for those points.
So now if I go back into like Gatling, so if I go back onto the report, so it's really detailed. We see we have some spike on the response time. Sometime we have some spike, but it's kind of like really kind of the same thing. So right now it's, if I take a point, it's like the mean is 204 milliseconds. The maximum is like it can be like 206. It's between 100 and 200. And also we can see that we kind of doing like six requests and response by second. So we send like by second, we send 6 requests and getting the response. And now if I just check like to compare between the two, to compare run. So now let me, yeah, so the point with optimization is on the left, so it's this one. So now if I just use like, I don't know, response time percentile, this one, here it's what you have. So because it take a long, first it take a long more time to just do it, and so it's like plus 200%. Because like right now here it's like what is optimized, so it's like like this one, it's optimized. Sorry, this
Okay.
one is optimized, and the one in green is not optimized. So even for, so like it's taking 200% more time for not optimized, which is pretty big.
It's very big, and it can be very meaningful for most applications.
Yeah,
And yeah, maybe we can show the optimizations again for people uh, on the audience that were binary quantization.
yeah,
We
wait.
also set indexing to 0 to the bulk uploading. Yeah, let's go over that. So yeah, we are setting on disk true. So basically we're putting the original vectors on disk. We are disabling the indexing, which m equals 0 in the HNSW config. We are going to update that later on so we can start the indexing process. But basically keeping the quantized vectors on RAM so we can speed up the search. And there it is, the binary quantization configuration as well. So
Yeah,
those, basically those two, right?
yeah, it's
And
kind
we
of
can
this.
already,
It's
yeah,
kind
and
of
we can
this.
already see the big difference.
So for example, for like response time for 99.99% of people, like right now it's like 68%. So like you lose 68% of time for sending point to Quadrant if you use a no optimized collection. So first you
Yeah,
can you can send more point to optimized collection and take less time for optimized collection. So it's like a
yeah, and
double win.
also again, we're using the scroll method here, not similarity search,
Yeah.
but also once you build the index, you can also test with similarity search and get even. I think I'm actually speculating here, but faster searches as well because of the HNSW index.
And also like for the output, which is like request by second. So how much requests we made to the application. With optimization, we made like a lot more of requests to quadrants. Like without optimization, we do like minus 70%. So you send more points much faster, and because we can like send a lot more of requests by second to quadrant.
Amazing.
So now if I just redo the comparison, now we'll just do the query, just need to rechange the so the URL.
We already leaked so many API keys here, Samir, that I don't
Yeah.
even think people are keeping up with it.
Oh, but you can use it. Typically, it's maximum, so you cannot send points. You can just query.
Yeah,
So
exactly.
as you wish. And now if I just like, yeah, it's a good one. I will just 7 notch. It will doing the query with optimize. But for example, what you can do with Gatling, like if I just take like typical user journey is you have. I know that a lot of people are using RAG with quadrants, even if like RAG is a good thing with quadrant, but it's not the only type of application you can build with quadrants. But a lot of people are using RAG, and what you can do with Gatling is you add a new features on your RAG. So maybe like something to improve the performance. What you can do with Gatling, you put like a new CI/CD. You can check if the query take more time or less time than before. But also like if you send a lot of points, if the collection is really optimized or not. So for example, it permits to do this. If or it can be just like you have an application, which is not a RAG, you have an application with a chatbot. You can directly check if when you add a new feature, if it's like a bad performance or good performance, for example.
That's lovely. And if you're in the audience and you have any questions, now is the time. We're close to hitting the 1 hour mark here. So make sure to drop those around load testing, Gatling, or anything that was done here using Quadrant. We're happy to answer those for you.
Yeah. And also, like if you want to see, like for example, because I talk a lot about RAG and LLM, if you want, like on the Gatling YouTube channel, you have a presentation about like all I have creating like an API for an LLM. I was just load testing this from with Gatling. So now if I see the report, I think it's not what we. But let me check. So if I just close this, yeah. So with optimization, but because I think it's also because I'm like west and not east, it take more time to get the answer.
Oh, I think we haven't. There's a few things there that we're not
But
really.
we have not done the indexing, so the indexing is not done also.
Yeah, we're still doing the indexing, right? So we need to probably wait a little bit for that to be finished since we didn't do it on the upload. And we are also, are we using similarity search for that one or also
Oh, the
scroll?
true one as scroll. Oh, no.
Yeah.
But let me just check. Wait, so yeah, but it's kind of the same thing without and with filters. Yeah, okay, it's mostly with filters that take a long time.
Yeah.
Okay,
So
okay.
if you're storing payloads on this, and also if you're not indexing the, this is actually a very good tip. Every time you do payloads, you add payloads to your points, make sure to index it as well, because then you can properly filter it and make it fast, right?
Yeah, yeah, it's on my side. So with that filter is like normal. It's like 200 milliseconds. It's with filter, like you said, because of you need to get the thing, which take like 1 second. It's with filters that take 1 second.
Yeah, there's a few optimizations missing there, but
Yeah,
really Interesting to see nonetheless. Everything working together so fast.
Yeah, and also like on like if you already develop with like Java or etc., it's really easy to create the Gatling load test. You just put the you just put the request inside a Gatling scenarios. You go into Gatling open source if you want to test it, and after you put it on Gatling Enterprise, and you can just load test it. Right now, I'm using one users for query, but you can easily add like 1 million users if you want, and just do like, and I will finish on it. But you can say like, okay, so I know that my users are from Sao Paulo and Paris. I can say I want the two, and I can say I want 60% of people coming from Sao Paulo and the rest from Paris. For example, you can say this, and now it will be like 40% of people will come from Paris, and you can do everything. Like you can do US East, West, Europe, London, Dublin, Paris, Sydney, etc. So it's pretty modular and permit to do a lot of things.
No, very, very nice. Yeah, and let's go to the Q&A. Do we have any questions from Gatling side? But
On
also,
no. Pardon.
just very interesting to also get your thoughts on, the most uh, vector search used use case, which is RAG or maybe agents, and how you imagine like Gatling being used also to improve the resilience of these systems.
So I think right now, like before it was more RAGs. Like every AI
Yeah.
meetup, every AI conferences was RAG, RAG, RAG.
Yeah.
Right now it's begin to being agents. Maybe thanks to like uh, chatbot because they begin to use like agents, for example. So they begin to be more and more agents for code. For example, on Cursor you can have agents to help you develop. I use it sometimes.
Yeah.
Uh,
And just a shout out to the Quadrant MCP that you can also add to Cursor. We just
yeah,
released a new version yesterday, so check that out. It's working really good.
but what I see in no, but like the thing is, Quadrant is pretty good because first it's written in Rust, so Rust is a pretty good language, but also because like the engineering team and all the person in the company really think about performance. It's not like okay, I will just like release the features. I don't know of search or indexing. They really think about okay, I want to do it, but with the best CPU usage, the best RAM usage. I don't want to be like a big thing. I just want to do it really fast, like really fast and with the best performance. So I think Quadrant is pretty good on this.
I do take pride in confirming that, Samir. I do think uh, our team, our developer team, is so amazing, and they're very, very focused in just improving performance 100%. Like, we are extremely focused on vector search and being able to retrieval and being the best at what we propose to do, and that's where it all comes from. So very happy to have those guys backing the product up and making
Yeah.
us work with something great.
And also like the documentation. In fact, the documentation is pretty good. Like sometimes I was like, oh, okay, how I do this with gRPC and Java, and like I just go like you can just go on the documentation. You have some snippet of code. So it's the same thing as Gatling with this kind of same thing. You have some snippet of code. You can easily like test it. And also like on Discord, even if a lot of person don't really ask question on on the good channel, but like you get a lot of answer from the engineering team, uh, dev team, engineering team, community, CTO sometime. So yeah, it's pretty good. So it's a really good community at Quadrant.
Oh, thank you so much. We're super happy to have you as one of our most active users there as well. I always see you
Yeah.
around doing great stuff. also at Gatling, all the events that you do and all the great stuff that you do, load testing and breaking stuff where you can. That's amazing. Yeah.
And also, yeah, no, but I'm like at Gatling, we have the chance to be like also really think the same thing as Quadrant. We really think about performance. So we really want, like for example, when we deliver features, we really want people to really love using it with the best performance. And also we have a lot of events because the thing with performance testing, like load testing, it can be on AI, it can be on web application, mobile. So we have a lot of events. And also like if you after the thing you want like to ask me question, to see the news about Gatling, you can just like connect with me on uh, on LinkedIn. I also have an account on Blue Sky. I don't really post on it, but I have one account on Blue Sky if you want. So this one is my account on Blue Sky. Yeah, you can see it's like mix of French and French and English. So you can come to me saying like bonjour if you want to speak in French. But you can follow me here, and you will have the full list of information about where I will be in which event and all the news about Gatling. And if you have some question after the thing, you can just ask me here. No problem.
That's amazing. Thank you so much, Samir, for this presentation, for breaking Quadrant Cloud for us, seeing how we can max things up.
I,
I hope, yeah,
even for collection is not really it's breaking because you cannot access the collection, but you just need to wait like 5 minutes is maybe optimistic, but you just need to wait, and after you can still sending like collection. But for the point, I
exactly.
break it. Like I break the size of disk.
Yeah, I mean, we maxed it, right?
Yeah,
We saw how much we can push it, and that was very very interesting. And you guys at home can try to do the same. Try to break Quadrant Cloud free tier. Try to make your experiments, and also I hope this also taught you guys about optimizing your collections and what you can do like easily with a few lines of code to make your performance even 2 times or 3 times
yeah.
better.
And
Yeah,
also like for if people are maybe asking or if people think about it, the code will be. I don't think today, but the code will be on GitHub. I will send it to you, Sabrina, to put it in the description. But I
perfect.
will I will put the code like maybe tomorrow, since like 6 p.m. in France. But maybe tomorrow I will put it on GitHub, and you can do some stuff with it with Gatling Enterprise and Quadrant. Because if you want with Gatling Enterprise, you have a feature, not a feature, but you have when you create an account, you have some credit, so you can test it. So you can test it with your free share of Quadrant, or you paid share if you want to see what happened, if you break it or not.
Exactly. We're going to leave it in the description of this video if you're watching after the recording. And yeah, thank you so much for everybody in the audience who hopped in. That was an amazing demonstration. And see you guys in the next Vector Space Talks. Bye bye.
Bye bye.